Okay, in this video, we are going to go over the rational root theorem. And the rational root theorem looks pretty complicated, but once we do a concrete problem, I'm hoping it's going to make a lot more sense. So, with the rational root theorem, we have a polynomial. And the only thing we're looking at is our constant piece and our leading coefficient. So, this is saying x raised to n. N could be like 5. If x is raised to 5, the next one is 4, 3, 2, 1, 0. But we're only going to look at the constant and this coefficient. Everything else we're going to ignore. And for this to work, the constant cannot be 0. So it says if there are rational roots, and that could be like a fraction, could be a whole number, it could be a positive, could be a negative, then it must be in this form. Plus or minus the factors of a sub 0 divided by the factors of a sub n. Again, we're going to do a concrete problem. One more thing to mention, what is a rational number? Rational numbers are made by dividing an integer by an integer. And integers could be whole numbers, they could include positive, they could include negatives, and they could include 0. And roots are numbers for x so that the y value is 0. So these are kind of good, important definitions that you should know. And so examples of rational numbers could be -5, -1/2, 0, 1/2, 1, 2, and 3. So finally, we're going to do a problem. This problem says find the possible rational roots using the rational root theorem. Again, we had a nice little formula, and it said the possible rational roots will be plus or minus parentheses factors of a sub 0 divided by factors of a sub n. And it's important to label that this point right here is a sub 0, and this 2 is a sub n. So I guess we can first focus on the 4, our a sub 0. What are the factors of 4? And to think of factors, you think of two whole numbers that multiply together to give us 4. And we know 1 times 4 is 4. We also know 2 times 2 is 4. So the factors of 4 are 1, 2, and 4. Next, we can do 2. What two numbers multiply together to give us 2? 1 times 2 is 2. And those are the only two whole numbers to give us 2. Okay, so once we have that, we just use our little formula. So plus or minus the factors of a sub 0. And you know what? I'll also label this as a sub 0, and this is a sub n. So a sub 0. One of them is 1, so you could have 1 divided by a sub n. A sub n includes 1 and 2, so 1 divided by 1, that's one answer, comma. Actually, I'm going to put a parentheses here, so all of these are going to be plus or minus. Next, we can also do 1, our a sub 0, divided by a sub n. A sub n could be 2. So we're going to get a bunch of answers, and these are all possible rational roots. In reality, only a couple of them will actually be roots. And roots is what value of x makes the y value 0. So next we're going to do the next a sub 0, so 2. You could have 2 divided by 1, and 2 divided by 1 is going to give us 2. Then you can have 2 divided by 2, this piece divided by this piece, comma. We'll do the next one. 4 divided by 1, comma, 4 divided by 2. And next we're going to clean this up a little bit. So we're going to clean this up and simplify this a little bit. So you'll have plus or minus. So we know 1 divided by 1 is 1. 1 divided by 2 is still 1/2. 2 divided by 1 is 2. 2 divided by 2 is 1, but we already have it, so no point in writing it again. 4 divided by 1 is 4. And 4 divided by 2 is 2, which we already have. So our possible rational roots will be plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 4. This right here is our final answer to this particular problem, but I'm going to explain why the rational root theorem is pretty important. And so we got our possible rational roots, and it was all of these numbers. The next step to actually know if you have a root is to plug it back into the original equation. So let's try 1. If I plug in a 1 here, I get 2 parentheses 1 raised to 4 minus parentheses 1 cubed minus 9 parentheses 1 squared plus 4 parentheses 1 plus 4. All you have to do next is use a calculator and you'll get an answer. And to save us some time, I went ahead and I typed it into a calculator, and these were the answers that I got. and we were in fact able to find 4 roots. This problem is x raised to 4, so there is actually only 4 roots. So this method is actually pretty useful if you can't factor. It narrowed it down. So this method allowed us to narrow down our possible answers by 1, 2, 3, 4, 5, 6, 7, 8. By 8 combinations. So you're able to test to find your roots by only trying 8 numbers. In reality, there's infinite numbers, and so if you were to just randomly guess to come up with these answers, it would take you, forever if you can't factor this problem. So that's why the rational root theorem is so important. Is there are situations where you can't factor, and this method will allow you to come up with the possible roots. And from there, all you have to do is plug it back into the original equations, and this will tell us the possible rational roots. Again, it won't tell us imaginary numbers, so there could be a situation where this, for example, could be a 4, but you only find 2 answers because some of them could have been imaginary numbers, some of them could have been repeating. So there's some limitations even with the rational root theorem, but it's definitely a useful thing to have in your toolbox. And that's pretty much it for this video.